Hey everybody, I welcome you to a short introduction to the basics of the C language. Later we do C++. C++ is basically an extension of the C language. So it went viral back in the days because it was delivered with a small compiler. And this compiler just translated C++ into ordinary C. So the developers could just stick with their own C compiler. They just had the advantages of the extension of C++, but no discomfort. So that's why it went viral back in the days. So for programming, we need two things. We need an editor. I use Gedit here on the left, and we need a compiler. So there are different compilers. I personally use GCC for C programs, and for C++ programs, I use a different one. It's called G++. There's also the Clang compiler and other compilers, but I just use those ones. Okay, so we can now program our first program. So let's start. Every C program starts like that. When a program is started, the Linux operating system and also Windows search for the main function. When it sees the main function, it jumps right into it. That's the first it executes, the first commands. And inside those braces, we can write down our commands, and those commands are executed one after another chronologically. So that's basically the idea. When a program finishes, we should return a value, because basically that's a function definition. We'll see the data, but we make a promise here. We say we return an int value. Main, this function, when it finishes, it will return an integer value, and integer basically 0 is an integer, so we can return it and it's fine. When there's an error, we return something negative. So far so good. Okay. So let's make the standard program hello world. So we want to print out something on the screen here on the right on the terminal. For that we can use the printf statement, and then the text we want to print out has to be in those quotes, and those quotes have to be in these braces, and every command ends with a semicolon. So that's what you see here, but those braces, they don't need a semicolon. So this is just a convention that those commands here need semicolons. Okay. So we cannot compile this because it will fail. It says, this is a bit cryptic here, implicit declaration. What does that mean? Yeah, it means it doesn't know what printf means. It never heard of this command. It says us the line where it happened. It's line 3. That's correct. In line 3 is this command hello world, and yeah, it just doesn't know what to do with it. It gives us a hint. It says node includes standard IO. So here's a background for this. The C language has only a very limited set of commands, like 27 commands or so. Only 25 of them are used. So it's a very, very limited language, and we have to expand the language quite notably to make it really useful. So I have this operating system here, Linux, and Linux can basically do everything. It can write files, it can read files, it can print something on the screen, it can make a diagram. So the operating system provides all those functions I want. In order to make use inside my C program, I have to import the files that declare those functions. So the C language comes not only with the language itself, but also with a bunch of files for every operating system that allows me to make use of this operating system. Without it, I can barely do anything. So in that case, to print something on the screen, we want to use a Linux operating system function. And how to do that is described in a file called standardio.h. And now the printf statement is known. It's defined in this file. Oh, that's not correct here. We don't say import, we say include. This weird hashtag here, it is what it is. And the file we include here is this one. And basically what the compiler will do then, it will copy the file inside our file here. It will merge them. So all code is accessible. So we can actually look into this file and find the definition of printf. Okay, now we can compile it and then we can execute it. So it's automatically a file.a.out is generated, and we can just execute it. And says hello world. Okay, nice. So this looks a bit weird here. We might want to have a new line here. So in order to do that, we have to inform the statement to make a new line. And how to do that? We do this by printing /n, and then it knows new line. We can compile it and execute it, and now the line ends here. If we want, so this slash here informs us about it. So if we want to print out just this thing, we gotta print it twice, and then it will print out what we want. So next thing are variables. So let's say x is 5. So, and this also fails because it says x is undeclared, doesn't know what x is. X could be anything. It could be an integer, it could be a string, a character, it could be a function. So we have to explicitly say what we want x to be. So we can say x, integer x, so it's an integer equals to 5. We can also do it in 2 rows, like integer y. Now we just declared y, and now we can define y being 3. And then we want to print out our variables, and we can do this with printf, but we have to inform it again that we want to print out a variable, and we do this by the %sign. And if we want to just print out a %sign, we just again write it out twice, and then we see %. Okay, but in this case, we want to print out our integer variables, and for that we have to inform about the type, and the type is integer. So let's say it's d is for integer, and we want to print out 2 variables, so we write it 2 times. And now we have to add the variables you want to print at those positions in the order it appears here, and we want to print out first x, and then first x, then y. Okay, 5 3 5 3. It's correct. So now we come to the thing which is important, because we will always have to resort to this assembly code in order to really understand what's going on. Later, the concepts will become a bit more complicated, and then there will be concept on concept on concept, and you really lose the track of really what's going on. So to ground ourselves, to root ourselves back into the real world, we have to look at the machine codes. That's why this stuff is so important. So to prepare the next topic, we have to understand functions. So let's do this. So we can now do arbitrary operations like y shall be x plus 5, and let's delete this one. So we expect y to be 10, right? So 5 plus 5 should be 10. So we compile it again and then execute it, and it says 10. Okay. We can also do things like, let's say we define y being 3. So we can now do stuff like y equals y itself plus x, for instance. So that means the old value, and this is all implicit here. The old value is 3, so this will be 3, and x is 5. This will be replaced with 3 plus 5, so y will be 8. So new old value of y, new value of y. But we use the same letter for both of it. So think of it as an assignment. Y plus x is assigned to y. So you can see y used to be 3, so 3 plus 5 is 8, and we see y is 8. Okay, so far so good. Now we can do a lot of operations, and what it comes down to is there are a lot of operations we want to do again and again, just with slightly different values. So we do not want to repeat ourselves all the time. This is also hard to maintain such a code. So that's why there's a concept of a function which we can execute again and again as a one-liner, but the function can be very complex. Basically, this is a function. The main function is just special because of the word main, and the operating system searches for it. But otherwise, it says the main function expects void. That means nothing. It expects nothing. And it returns an integer, and the value we return 0. So that's already a function definition. What that concretely means on the other side, so when we want to start our program a.out, often you can add options like version or something, right? So in this case, that's not possible. All options you add will be discarded because it says void. If you want to make use of those options, you got to write something different. Okay, but we want to declare a function of our own. So let's say we want to return an integer, and let's not return anything. Return void, so it doesn't return anything. It just returns without returning a value. My function, and it also expects nothing. So a function that does not expect anything and doesn't return anything, is it any good? And the answer is, yeah, maybe we can print out hello world. And of course, we can enter here more commands like printf hello. What we can do now is we just delete all the stuff here, and then we execute, or we call our function, my function. And in order to execute the function, it's not enough to just write down the name. We have to add those braces. So let's see whether this compiles. Oh, I was missing a C. So it says hello world and hello. I forgot to add the /n, and also here the /n. And now it prints out nicely. Okay, cool. So maybe we want to do some mathematical operations. So we want to hand over some values, like an integer called a and another integer called b. Those names are valid only inside the function. We will see that later, what that means. And we return also an integer. And what we do is we just return a plus. That's it. So when we now want to call our function, it fails because error, too few arguments to function, expected 2. Yeah, it expects two parameters, but we provided 0. That's correct. There's no parameter inside here. So what we can do now is we can define a variable like integer x, and then we can say x shall be the return value. What shall be x, and it will be the return value of my function, and we hand over, let's say, 2 and 3. So we would expect x to be 5 because my function called with 2 and 3 means we just return a plus b, so we return 2 plus 3, that's 5, so x should be 5, right? And then we can print it out. And it says down here x is 5. Okay, cool. So we can call this function now again and again. And no matter how much code we enter here, we just have to call this one line and it will just work. So functions are very useful, and they are also very important for our next topic. So I said last time, I think I said it in this video too, I'm not quite sure. When we go to concepts of C++ and so on, it will get, there will be concept on concept on concept on concept, and you will just lose track of what you're actually doing. So in order to understand what we're doing, what actually happens under the hood, we have to resort back to machine code, and we have to understand a bit more about those assembly language in order to really understand what the stuff means we write down here. So how does our mental model relate to the actual implementation inside the computer? That's why I introduced functions. And next time we clear up your confusion about System 5, and you will be positively encouraged, highly encouraged to go on and learn much, much more about the stuff. Okay, stay awesome. See you next time.